This video is going to talk about GCF when we're factoring polynomials. So greatest common factor. And GCF is something you always want to look for, but especially when you don't think you can factor. If you are looking at a polynomial and it doesn't appear to fit any of the patterns we've learned, it's not a square, it's not perfect squares, it's not for perfect cubes, it just looks funny. Check for a greatest common factor. Do all of the numbers divide by something? Do they have a variable in common? Take that out first by dividing, undistributing, and then see what happens. So here we have 2x to the fifth minus 128x squared. So x squared is an even exponent, but x to the fifth is not. It's not cubed, and neither of these numbers are perfect squares or perfect cubes. So it would appear this doesn't factor. However, if we notice the numbers, 2 and 128, well, they're both even. So I can divide 2 out of both of those. And then I have x to the fifth and x squared. Well, they have an x squared in common, right? X to the fifth would be 5 x's. X squared is 2 of them. So they both have 2 that they share. So I'm going to divide x squared out of both terms. Okay, I cannot take any more than the smallest exponent, though, so remember that. Okay, so when I do 2x to the fifth divided by 2x squared, if it helps you, you can write it in here. 2 divided by 2 is 1. X to the fifth divided by x squared, we subtract, and that's x cubed. Just bring down my minus sign. 128 x squared divided by 2x squared. So 128 divided by 2 is 64, and x squared divided by x squared is just 1. So this is it, actually, x cubed minus 64, okay? So I have my 2x squared out here. This is going to need to stay in my answer, even though I can't do anything else with it. Now let's check what we have in this binomial. X to the third, well, that's a cube, and 64 is 4 cubed. So this here is a difference of cubes that I can factor with my difference of cubes pattern, right? So my a minus b times a squared plus ab plus b squared. All right, so let's take a look here. So again, my 2x squared is just there. It's just going to be in the front now of my answer as it works its way down. All right, so my a, the cube root of x cubed, is just x. And the sign matches. The cube root of 64 is 4. All right, and then it's a squared, so x squared. Opposite sign, so plus. A times b, x times 4 is 4x, and then b squared, so 4 squared is 16. Remember that sum and difference of cubes don't factor anymore after this. So just make sure we have our 2x squared as part of our answer. We factored our difference of cubes, and that one is done. All right, so for this one over here, it's a trinomial, but the exponents are not even, they're odd. So we're going to have to see if we could do something and take out a GCF here. All right, so I have 3x to the fifth plus 15x cubed minus 108x. They all share an x, and all of these numbers are divisible by 3. Again, usually it's safe to start with the smallest number, your smallest coefficient, and try that. So if I divide everything by 3x, let's see if what we get left over will factor with one of our patterns. So 3x to the fifth divided by 3x is going to be x to the fourth. 15x cubed divided by 3x is 5x squared. Remember, when you're dividing your exponent terms like this, you subtract. And then negative 108x divided by 3x, the x's cancel out, and it's just minus 36. So now I have a trinomial with an even degree. The middle exponent is half of that degree. So this would follow our quadratic trinomial pattern. Okay, so remember, just whatever your GCF is, just have it in the front of every step you do. Okay, so I should be able to factor this like a quadratic trinomial. But the x to the fourth, right, I take the square root of that. What times itself is x to the fourth? Well, that's x squared. Just take half the exponent. All right, so x squared and x squared. Now I just have to find two numbers that multiply to negative 36 and add to positive 5. You may use the x method. You may just do it in your head. So think of the factors of negative 36 that would add to 5 if we do positive 9 and negative 4. They would multiply to negative 36, but they would add to 5. So that's what we need. We need x squared plus 9, x squared minus 4. And we might say, okay, phew, we're done. We got everything factored. But remember to always double check. Once you have factored, see if anything will still factor. And notice if you look carefully, x squared plus 9 is a sum of squares. A sum of squares. And x squared minus 4 is a difference of squares. So I can factor both of these even further. Okay, so my sum of squares is a plus bi, a minus bi. So the square root of x squared is x. The square root of 9 is 3, 1 is plus, 1 is minus, and because it's the sum of squares, I need my I. So x plus 3i, x minus 3i. And then my difference of squares, a plus b, a minus b. The square root of x squared is x. The square root of 4 is 2, so I have a plus 2, minus 2. Again, I don't need I because it's a difference, not a sum. Okay, so now just looking through, no more even exponents. All these exponents are 1, and no more perfect square numbers. Okay, so that's how I know I am finally totally done with this. One other thing you can check if you're wondering, how do I know if I could still factor? If you take the exponents of every factor you have, they should add up to the original degree. So notice I have 3x to the 1, x to the 1, 1, 1, 1. So that's 1, 2, 3, 4, 5. All right, so that's how I know for sure I've factored everything down because they're all just in ones and I can't go any further.